ấy thì bởi nó không to này bám vô cơ sở nó bung ra luôn á, cơ sở là bài này to khác nhau nên là nó chỉ từ đó bấm slideshow bên ngoài này rõ chưa? Anh không làm được.
No.
Sao bấm không sao vậy ta?
Eu tô descendo lá pra baixo.
Can we start now?
Yeah.
Yes.
Sorry.
There's no one.
Okay, see my team project about AI training data selling with privacy protection for client. About my project, my problem I want to solve is how can data provider can sell data without compromise the privacy of their client. The problem is here, I have a legal data holder, example a hospital, they have many clients and they can collect the data, can image like X-ray image or skin image or anything else about the client. And another, we have a model holder who have an AI model and want to train on this data, but they cannot access this data. They can pay for buy this data and train model. But the transition will be not occur because it will hurt the client privacy, because when the user when the data holder gives the raw data to model holder, it will review the data of the client and it will not good for client privacy. So I want to design a protocol that makes this transition can occur. The model holder can train its AI model and the data holder can get the money. Okay, and our proposal is like that. First, we focus on the CNN model. It will have structure like that. The first layer will usually a convolutional layer with another will be map pooling, another convolutional layer, and finally it will be a fully connected layer. And when the inputs go through this structure, after computation will give output is the model inference. So the model holder one has input and input in the data of the Lego data holder, and we focus on our proposal will focus on this layer. The first layer is the convolutional layer. The model holder will send the first layer to the data holder. The data holder will and delegate the computation step of the first layer to the data holder, and the data holder will get its data and compute to get the result, and they will generate a proof that say they have a compute correctly. And after that, the data holder will send the result and the proof to the model holder batch, and from this result the model holder can continue change their data model by put the result here and continue run the rest. Okay, and it's not different with the basic, but it only delegates the first step to the one who has the data, and after do this step, the raw data will be transformed to another form that can yield in another step in the training page. But the result here will not reveal and reveal about the raw data. Example, we have the image as the input, and after go through that, it will be a vector. It will not. We cannot reconstruct to a raw image again. So it will not reveal and not compromise to the privacy of the user, but it can reveal something about the distribution of the data or the future of the data. But the main that we focus is the raw data, that from the result it cannot reconstruct the raw data, and here is what we focus. Yeah. And we will go to the detail that if say we have n data piece, and we each data piece will go to the computation step through the first layer, and it will generate the result and the proof. From the 1 to n, we have n result and n proof. And we observe that we can aggregate n proof to top 1 through 10 to the aggregation 40, and the result we will concat to 1 and give back to the by the eye holder. Okay. So in this I saw the problems that solve problem about the privacy of client, but we have two parties, the data holder and the model holder. The model holder want to know what is correct data. Say that if the model holder want train AI model on a medical like X-ray image, but the data holder use another image like a landscape. Here, after they can run this image and have a result and a proof. And when verify it, we also show that it's true. We don't see about the original image or the original data, so we cannot sure that this data is what we want. So it is a problem because in the first phase we say we can protect the privacy of the client, but we must solve the problems that the model holder who buys the data will also have the benefit of this data. So this is the problem, and we provide the solution for that, but it's not perfect. It is only a solution in that case. Okay, say we have n data, and for the data is data A, I will separate it. I will split it to example four piece of data, and I will construct a macro tree for the data. So for n data piece, I will have the macro tree of all the data that I will base, and then first the Lego data holder will build the macro tree and send it to the model holder, and then the model holder will do the Monte Carlo check. It will give the query, and the data holder will give the original piece of data to the data holder to check. Example, the model holder can query, give me the first bit of the data as index 100, and the data holder will cut Zupply and send the original data to the model holder. I see, and the model holder will verify that. First, we will verify two steps, two things. First, does this data is what the model holder needs? Say the model holder want iterate data, so this piece of data must be an iterate. If not, it's a landscape or the image of the dog or a cat. Okay, and it will have the data piece and compare to the macro tree. The list in the macro tree is equal or not. If not, the Lego data holder is cheap. Okay, and it's only a Monte Carlo check because we cannot check on the data set. It's the end query will be defined by the protocol. It will do until the model holder says, yeah, it is enough for me to agree with the data set. Yeah. And after that, so when this page will done, the model holder and the data holder will agree on the data set that the data holder will commit at the beginning. And so the proof generation will see like that. The data holder will prove that the image as a private input. The computation logic, you will see it as a computational layer. The result as output, and the macro tree. These three things will be public, and this is private, and we prove it to the proof. If verify the proof is true, we say that the data holder will have to do the right computation, and we say the second thing that the input data here is in the set that two parties have agreed at the beginning. Yeah, and finally, it is an overview of the basic flow of my project. The first phase will be the commit and agree on the data set. The Lego data holder will commit the macro tree to the model holder, and model holder will do some Monte Carlo check to verify that if the data set is what he wants. And after that, if two parties agree on the data set, the computation and but and pay will go through. But if not, cancel. Okay, and after we two parties agree on the dataset, the model holder will give the first layer to the data holder, and data holder will run this with its data and give the result and the proof, and then give proof and the result to the model holder, that they can verify that proof and use this result to continue training the model without any thing else step. Okay, and that's all of my project. And I think the main thing of my project is different from another that's by on federated learning is that first we have an addition step to ensure that two parties agree on the dataset, and the computation of the data holder will be less than. Instead of give on the model to the data holder, and the data holder will giving a proof that they do all things correct. We only use the first layer, and this will make the protocol more efficient and not put the heavy computation on the data holder. Yeah, and that's all. Thanks.
Is there any question?
Any suggestion?
I don't know anything about sorry.
I can just say that this is great to see like the mixture of like basically optical science, I'd say, into like the CKs and stuff. It's like big thumbs up.
Yeah.
Yeah.
Thank you. So,
Okay, thank you.
Okay, so let's do a brief recap of our projects, what we're doing, and I'll briefly introduction of what we done last week. So our project is called Zip Code, and we're trying to prove the code contributions in some private code base, and we're focused on the GitHub. And
Can you talk a bit louder?
what?
A bit louder.
A bit louder.
Yeah.
Okay. Do we have the microphone? No. Oh. So actually what we already built is we built a platform that automates the reward distribution to millions of developers and tracking recording their contributions. As I mentioned last time, we have a way to redistribute the reward, and we think it's fair. And that's how the system works. And one major problem is how to record the contributions on chain. Originally, it should be done by some oracle in a decentralized way, but currently there's no oracle can contain the data like GitHub, and it will be expensive. But actually, we can sign each commit offline, so we can generate some proof. By ZK technology, and what we already do the demo is like this. Suppose we we have a repo, and we can fetch all the commits directly. There are so many things. We don't reveal any information that user don't want to reveal. Maybe we can reveal some hash, and we can prove that, and the result will be like this. You can generate a proof, and the original idea is we want to use some commit to prove that the contribution, and we don't need a repo, but just let anyone have the access to this repo, they can generate a proof. But after we try to integrate with our system, there is some problem. The first is that if you do some GitHub rebase, and all the commits hash will change, and also our system, what we're doing is actually we're trying to prove some pull requests and the issue closed, and it's actually not commit. So after we're trying to integrate, we face some problem. And currently, what we're doing is we'll register some fake email and to get some and subscribe the GitHub organization, and if the pull request opened or the issue closed, we can get email from the GitHub, and we can and since the email is controlled by our service, we can directly make some ZK proof. But we're still doing the research part. It didn't work currently, so that's part of what we do last week. And another thing is we are really excited to announce that our platform has just released our beta, and the domain has been changed to According.Work, which means we are doing a platform that tries to reward everyone according to their work, but not according to your boss or what your boss said, like you are a good employee. But we can directly from the GitHub contribution histories. So let me do one thing is actually currently it's already everyone can access it and everyone can use it. So let me do a demo how to use it. Currently I'm working on this ZK code project, and as the owner, the only thing I need to do is I already log in. The first thing is you need to log in by OAuth. And after that, you need to authorize us, let me access some of your organization. And currently I can access the ubet DAO and select the repo I want to import, which is the ZK code. Yeah, and I can import it. And it will automatically fetch all the issues like this. Sorry, it's another repo. This one. There might be some problem. Yeah, but as you can see, this is the issue I just opened, and as a developer on this platform, but not the owner, you can apply this. How do I say? This task, which is actually the issue, and as you can see, the user now left a message here, and so the owner can assign him because he left a message. So he actually can see it on the assignee list. But let me unassign it. You can also do it in your platform if you are the owner. So you will see there is a task apply, and that is what I just did. And if you click approve, the assignee will also change to me. And after, if you open some pull request and close this issue, all the contribution will both save in our database and also save to be saved on edu chain. And the next thing is we're trying to integrate ZK code with our system so that no one need to have the super board to record it. And but anyone with the valid email proof from GitHub can do that. Yeah, so we will still do that for everyone, but it's not centralized. Yeah, because everyone can do that. the smart contract is online, is public. Everyone can see. We do not do any trick here. And we're also doing some tutorial. Currently, we're also working on another tutorial about cryptography, some basic knowledge. And you're welcome to work with us. And anyone interested in our project, you can use our platform, and maybe it can help you to gain some reputation and gain some contributors because we already have some users. And that's what we done last week. And our beta is just released yesterday, which is the 1024 festival. And if anyone interested, you can scan this QR code to follow our Twitter. Yeah, and that's all. Any questions? Okay, no question. Thank you.
Your phone.
Okay, let's begin. Hello everyone, I'm Shan. We are the team of proof of Invisibility. Actually, I have another two team members. One is having a meeting outside. The other one is Peter staff. Actually, he got sick last week, so only I am here to give you guys some updates from our last week. And by the way, the doctor says the beer stuff is from the unhealthy lifestyle and the stress. So health is our first priority. Yeah.
Yes.
So everyone feel free to show your support and care to be here when next time you see him here.
Is he resting somewhere?
I'm not sure. Like he has some fever.
He went
and-
to the doctor?
Yeah, went to the doctor and went to another hospital to check.
Okay.
And he's not stressed from our project. He's just from his own project.
Okay.
Yeah, maybe he has too, like some device.
Yeah.
Yeah. Okay. Let's talk about our staff. And I think somebody, most of us already know, but let's give you a quick recap about what we try to do. What we try to do is to replace the Dennis, or right now it's the me. Every day we come here, we need to check in. So we try to did it ultimately, and we try to use ZK to protect our privacy, protect our sensible data. So basically our idea is, because in the Invisible Garden, we still need to record the attendance. So we need to make sure who already checked in and who doesn't show up. So we still need to record the attendance. So for in this situation, we choose to protect our time. Like right now, we need to show up at 10, but in the ZK circuit, we still can make sure that everybody, the first show up time is 10, and then just to make sure, and you can in and out, you have several tracks of your day, and then at the end of the day, you can generate a proof and prove that you already done 8 hours or 6 hours work at here. So that's the basic idea of our application. We just to do something fun with ZK, not hardcore with that. Yeah. So that's the kind of like an overview of what we try to do. The key component is the checking app, the ZK proofs, and NFC device. And actually, this is the update because last week when we present, we choose the GPS to how to say it, to show like we actually here. Yeah, because the key point of the verification is the people, location, and the attendance. So last time we use the GPS, and this week we changed to an NFC step because a lot of people are saying like the GPS is really easy to cheating, so it's not reliable. So we choose the NFC device instead because the NFC is physically can pretend, not pretend, like physically make sure you were here, and also the NFC can give you some data to help you to do your proof later. And that's the technical architecture. So first we have the front end. This is also an update. So last week we tried to use the a teachable or Discord board like minimum the front end stuff. But later, as our technical design already changed, we need to store some data at the local storage. So we found out and also we need to generate the proof at the local store, like the local device. So we think maybe it's true. From our knowledge, the TG boat and those boats cannot take that. So maybe we need to do that native app. Yeah, and if anybody knows, there's another solution. Please tell me. Yeah, and then we have the backend. The function of the backend is verify the ZK proofs and record the attendance data. And the ZK proof can make sure our security. That's the workflow of our application. So basically, this is the phone. So every day you come here, you tap the NFC device, and then the action of tap can make sure you already show up here, and also the NFC will send you the timestamp. So the timestamp is not from the user side; it's from the physical NFC device. And then there will be a private key in the NFC device and assign those messages and return your data. And actually here is the thing I just mentioned, you can have several records in one day. And at the end of the day, we generated the ZK proof and some of the proof. And then after verify, we record the data to the database. Yeah. Okay. Yeah, and right now we already done some circuit, and here. So it's quite simple. It's not a really complicated one. This check is just do the time checking, but it's not the final one. I still need to add some logic. And this one is the signature verify. And the most struggle thing for us maybe is the front end. Sorry. That's all. Yeah. It's at this page I try to mention is although we think that those mini app in TG Bolt or Discord Bolt cannot work. But at least we try not to generate the proof on your phone because nobody wants to use your computer, your laptop to do the checking. So we try to build the proof at the minimal size. So please, if you have any suggestion about how we can build the circuit and how we build the proof system, welcome to give some suggestion and
You can to my vision, I think delegate the proof will
delegate the proof to somebody, to some service.
Yeah.
But that means I need to incorporate my data and then to them.
There is sometimes that you cannot.
You need to secret share that first.
Yeah, secret set.
But my point is I don't want to expose my personal data to the service, so I need to encrypt and then make them.
Secret sharing is basically the same hiding.
Yeah.
You don't quite encrypt, but you hide the information. And since you work with Circum, there is a collaborative Circum, co-Circum, from the CEO team, and that might, I mean, if this approach, that might be the easiest way to implement it. You secret share your data on the client, then send it to the like a bunch of MVC servers, and they do the proving. But it is like fully private.
Okay. Again, we can discuss later afterward. Thank you. Thank you to give me that suggestion because if we can do that, then we can move back our front end to the mini apps. We don't need the native app to do that. But still, because we need to collect the data and we need several, we need a little bit local storage. So the TG vote, those votes can or no. Let's figure out later.
Okay.
Thank you. Thank you, guys. And remember, next time you see Biostat and
Yeah, already.
Yeah.
This is the file.
Discord username? Do you know his Discord username?
Discord username. Yeah, yes. So it is my first time on the stage, so it is to share some idea of mine. Just come up with some ideas with the talking with other people. So this is a very initial idea. I come up with an idea of Zupply, and there's a Zupply-based supply chain finance platform. Why do we use the Zupply platform for supply chain? So let's explain some current state of the supply chain finance. Supply chain finance is one of the ideas. I have talked with some bankers, and they want to come up with some supply chain for blockchain. So right now, the very famous is the Apple supply chain. Apple supply chain right now is the very biggest supply chain finance. So we have supply chain all across the world. So the internet. We have very international manufacturers from every country. So there is a growing global flow capitals, and right now the traditional supply chain market is over 100 billion markets. We use the Zupply and blockchain. We use innovation in infra for supply chain. I call it SCFI. Why do we need a blockchain? Because it has a special advantage. We can use Zupply base to secure for security and privacy. Because for business data we have much more need for privacy. So we can use the pay file for interoperability and scalability. And so we also need some DIDs to approve some license and the other things, and to do some automated verifications. So on-chain, we also use the on-chain analytics and transparency.
How to use the zero knowledge? And we can prove some suppliers and orders because but we cannot reveal the orders info because if we have push those information online, your competitors will also know the info and they will also compete with you for the suppliers maybe a lower price and much more orders and they know the order because it is such a privacy for business information. So with this information, we can give us a proof and we can loan from the bank and some collateral loans and from the with the charts of your proofs. So the blockchain can with the blockchains the transaction on chain, so we can prevent some double loans. We can chase the loans where to go from. So with the zero knowledge, we can hide some the following information. So the first is suppliers. Supplier is very important. So we don't know the suppliers, so we can just don't know where your stuff goes to. What is the biggest suppliers? But we can have a list of the top suppliers. So the other is the order amount. The order amount means that the order amount, how big is the amount you have to loan and you have to need those money for. So if you have bigger amounts, some very small manufacturers they don't have enough money. They have to loan some money from the bank or from the other institutes. The third is the license. The license is a very old method. It's like DID. I have did Web3 CDID, so it can prove any license or any passports for you. Those are the use case of the exactly zero knowledge. So what is the implementation? I think the most simplest way to use this is the Zupply email, because we usually do some business in some email. We will confirm our order. We will contact with suppliers. We often use emails. So I come up with a use case for Zupply email. With the Zupply email, we can use some supplier widgets. We can hide those suppliers. Like you have a list of suppliers on our email. So if it matches those suppliers, we have contact with those suppliers. The second is the amount, the order amount register. The order amount means how big is your order is to. So you can gain what's the amount you have to learn from the bank. So capitals. And the third is I come up with the license for DIDs. So DID in some district some license is the threshold for you're going into those markets. But sometimes we must hide those licenses up where your competitors may also apply for those licenses. It's also a barrier for this commerce. So license, all those licenses can store in IP address, but we can prove them on our signature or our proofs. So with those charts those proofs, and we can do some correlated lending on chain. We can show our proof of those suppliers and order amount. So we can gain trust and loan from the official institution and capitals without state any assets. For the prospect, it is very beneficial for the government. I think for the government they need this to improve their industrialize, and so for many manufacturers, and they just need money from some very big institutes, and they must earn money, and they must to have some instant money for they running into those and produce those products. Thanks. One more thing. I think some in this I always think about some use case of the zero knowledge, but in the right now stage, most of the people they just research on some very hard ZK algorithms. But most of all, the ZK right now is the performance the performance and the user case is still very lag in the market or in right now stage. So I think for in one aspect, so the ZK is much expensive for those companies to work for. So many little companies they cannot afford this. So with the ZK, most of the people they sometimes they don't want to hide their privacy. So maybe some rich people. So in our products, maybe we are just focused on some very big companies or capitals or governments. So that's some ideas of mine. Thank you. Yeah. Next.
Can you share the slide?
Yeah.
Can you share the slide?
Oh, yes. It is one of some of the ideas I used to. Yeah, I can send you.
Nice.
Hi. So, where are we with push staking? So basically, the project for push staking is to transition to push core v3, which makes the architecture more modular and integrates with staking. So I have a repo ready, and basically the purpose of the repo is to upgrade from push core v3 to push core v2 to push core v3, and to create a more modular contract architecture. And basically what this does is it separates core protocol logic from staking and fee distribution logic and mechanics by the creation of a push staking contract. So currently what we have is a push core v2, and this one contract, it goes beyond the size limit of acceptable contracts, and B, it handles all the core protocol functionality, which is channel management, notification management, staking, fee collection from the channel management, as well as staking epoch management, reward distribution, etc., etc. So basically, it's like this giant contract, and so we're doing now separation of concerns with push core v3, where there's a separate push staking contract, and then a push core v3 contract. Okay, so what push core v3 includes, it retains the push core v2's functionality regarding channel notifications and management of that, as well as fee collection, because all the rewards for staking are assembled from people paying for the use of channel management as well as the notifications. So basically this contract still PushCore pulls these fees, and it manages and it relays the reward distribution as well as epoch management as well as to push staking. So basically, it integrates with the new push staking contract, and it speaks to the interface of that contract. So I went over the differences, but in a nutshell, basically, it offloads staking and fee distribution to push staking. It allows push staking to pull fees from PushCore v3. So a new thing is that now with this separate staking contract, staking will no longer only apply to token holders, but staking will also apply to wallet integrators, which means other projects that integrate with push. And when they integrate with push, their wallet addresses becomes a staker that can get rewards. And so these wallet integrators are added and removed by governance. And so when governance adds a wallet, this action is like the equivalent of stake. And when they remove the wallet, it's like unstake. Also, the staking rewards. So basically, fees are pulled from push core v3, and those are the rewards. So when they enter into the staking contract, they are separated into two different reward pools. One reward pool for token holders and another reward pool for wallet integrators. And the percentages of how much goes to token holders and how much goes to integrators is varies. And also this value needs to be updatable by governance. So basically, I'm going to go over the repo in a second, but so push staking is a new contract. It handles all the mechanics of staking. It pulls protocol fees from push core v3, separates it into two pools, distributes rewards to the stakers, as well as configures reward distribution, how much percentage goes to either pool. So just focusing on some of the functionality. So to pull fees from push core v3, there's a pull protocol fees function. And basically this function is called to push core v3 and transfers the fee to the push staking address. And then the fees are divided into which goes into the wallet amount, which goes into the token holder amount, and the amounts are separated with regards to the right percentages. So the transfer protocol fees, which is, so this function is actually called automatically whenever a new epoch is initialized, basically. So a new epoch is initialized whenever there's, an epoch is 20 days long or 21 days long. And so basically, when that time comes, when someone is staking, the contract checks whether we're in the same epoch or a new epoch. And if we're in a new epoch, then the fees that people have paid for channel and notifications and management, the part of it that's supposed to go to protocol rewards is pulled from the core contract. And basically it's this pull protocol fees calls the push core contract, and it calls in it a function called transfer protocol fees, and it pulls them to this contract. So the transfer protocol fees, actually this one needs access control because it should only be called by the staking contract. It shouldn't just be like external. And basically it does what I just told you, and then it reduces the amount retrieved from the overall protocol fee. And then here you see the functions for configuring the fee distribution. So basically, like we said, initially the contract's going to be set such as 70% of fees go to token holders and 30% go to wallet integrators, but this value needs to be upgradable. So basically, also this needs to be access controlled by governance, and actually it is only governance, and only governance would be able to change these percentages. So I'll tell you the next steps and then I'll show you the repo. So basically, next step is, so right now, the way push core is upgradable, so it can't hold any state within it. So how this project handles state is that it had these external contracts that contained the patterns for the state. So because there's a new variable in the push core, at the moment only two new variables. So these new variables need their own state contract in order so that the storage layout doesn't get overwritten or messed up. And so right now all the functionality that I discussed before is in the contract, except for the integrator wallet. So I'm missing the two functions for governance to add wallet integrators and to remove them, i.e. they stake and unstake. So that's what's missing from here. And then after that comes the test suite to test that everything is actually functioning as expected. So, all right, so this is the contract. So basically, like the repo, obviously cloned from the push repo, it has a folder for like the comms, then the folder for all the versions of push core. So push core v3 lives here, and these are the two storage contracts that are inherited by push core. And then now in this push core v3, which is upgradable, and it contains all the functionality of push core v2 except for the stuff that I just talked about. And so you can look at this if you want the link to the GitHub. But basically, that is that contract. It's still in progress, needs cleaning up and adding an aspect, etc. And then a push staking folder that implements the staking also needs description, etc. But basically, this is the code and the functionality for that. And the code compiles, but obviously the truth will be revealed once the test suite runs perfectly. But the existing test suite runs. Yeah, so that's it. That's where I am. Questions? Okay.
So I think we can make a break. There is another one at 4:30.
Okay, great.
It's quite simple. It's basically a translation. So it take about you know to read slowly.
So it's like so it's like one
You type your data, you encode it as coefficients, or usually something yeah. You have your polynomial, and then you just like sample a few more points from that polynomial, and send the data like those points, and then so the test is like it doesn't contain your original data, but if you sorry, you tell something like wait, but like where you combine a number, like enough of those like points, you can control to get back the data. Like things you get the and then who needs to know like or like new data originally will be able to like get the data because he knows which coordinates.
So we get all these points and then you have to also you can like create your own encrypted data that way.
So now you are thinking about yeah. So it's essentially like an NPC.
Actually, so you can get all the points for like a single